Hey everyone, welcome back to your channel name. Today, we're diving deep into one of the most mind-blowing scientific advancements of our time, the discoveries made by the James Webb Space Telescope. Since its launch, this marvel of engineering has rewritten what we know about the universe, from peering into the cosmic dawn to uncovering the secrets of distant exoplanets. If you're a space enthusiast or just curious about the vastness of the universe, stick around because this video is going to blow your mind. Let's get started. It's been 3 years since NASA launched the James Webb Space Telescope on an ambitious mission to uncover the secrets of the universe's earliest days. Think about it for a second. Someone had the idea to build a telescope capable of peering back to the Big Bang. Mind-blowing, right? James Webb isn't just a telescope. It's a time machine, traveling billions of years into the past to help scientists understand how planets, stars, and galaxies form, evolve, and ultimately fade away. Along the way, it's gifted us with some of the most breathtaking images humanity has ever seen. So, what has the James Webb Telescope discovered so far? Let's start with the Sombrero Galaxy. With Webb's mid-infrared instrument, we're not just looking at the bright core visible in traditional images. Instead, we see a smooth inner disk and intricate clumps within its outer ring. Honestly, it doesn't look much like a hat to me, but it's undeniably stunning. Then there's the discovery of a ravenous black hole at the center of a dwarf galaxy, dating back about 1.5 billion years after the Big Bang. Using James Webb's data, astronomers found that this supermassive black hole is voraciously consuming matter. The James Webb Space Telescope has given us a front-row seat to the wonders of the cosmos, uncovering secrets that help us understand the universe and maybe even our place in it. At a rate over 40 times faster than we ever thought possible, this intense accumulation of matter, though likely short-lived, offers groundbreaking insights into the rapid growth of supermassive black holes in the early universe. Now, let's talk about Vega, one of the brightest stars in the night sky. Thanks to the combined efforts of the James Webb Space Telescope and the Hubble Space Telescope, we have an unprecedented view of this celestial giant. Hubble's observations reveal a vast, smooth disk made of fine dust particles, while Webb's infrared imaging picks up the glow of warm dust in the disk's outer regions. Here's the weird part. This disk is missing the clumps or gas typically linked to large planets. In other words, Vega is out there in space totally alone, just hanging out with a bunch of rocks. Next up is this stunning composite image that combines Webb's mid-infrared data with Hubble's ultraviolet and visible light observations. It captures two spiral galaxies locked in an epic dance of interaction. The vibrant colors highlight regions rich in dust and gas, the essential building blocks for star formation. And then there's Centaur 29P, a curious mass of rock and ice orbiting between Jupiter and Neptune. What James Webb captured here is, well, basically a giant asteroid fart. Using its near-infrared spectrograph, Webb detected two types of carbon being released. Whether it's unveiling the mysteries of black holes, star formation, or even cosmic gas clouds, the James Webb Telescope is giving us a whole new perspective on the universe, one fascinating discovery at a time. James Webb has spotted something truly fascinating on Centaur 29P, jets of carbon dioxide and carbon monoxide blasting out from its surface. Essentially, this icy object is venting gas into space, a cosmic spectacle we're lucky to witness. Now let's dive into a galaxy unlike any other, located about 1 billion years after the Big Bang. What makes this galaxy so unusual is that its gas shines brighter than its stars, a rare phenomenon. Scientists believe this could represent a transitional phase in galactic evolution, bridging the gap between the universe's first stars and the more mature galaxies we see today. Speaking of galactic drama, check out this pair of galaxies locked in a cosmic collision 465 million light-years away in the constellation Leo. One is a spiral galaxy, the other an elliptical galaxy, and their gravitational tug-of-war has distorted the spiral's arms into fascinating shapes. It's a cosmic ballet of destruction and creation, beautifully captured by James Webb. Closer to home, well, relatively speaking, Webb has turned its gaze to the outer rim of the Milky Way, also known as the extreme outer galaxy. Using its near-infrared camera and mid-infrared instruments, Webb has revealed breathtaking star-forming regions hidden within two molecular clouds. These images show young, massive stars and intricate structures of gas and dust shaping the very edge of our galaxy. The James Webb Space Telescope continues to unlock new chapters in the story of our universe, one discovery at a time. Here's something straight out of a sci-fi novel, a galaxy that resembles a cosmic question mark. This intriguing phenomenon is the result of gravitational lensing, where the immense gravity of a galaxy cluster bends and magnifies the light from a more distant galaxy, creating this iconic shape. James Webb has also made some jaw-dropping discoveries about the universe's early days. Initial observations revealed massive, super-bright galaxies existing just 500 to 700 million years after the Big Bang. These galaxies appeared far too large and luminous for their age, challenging everything we thought we knew about how galaxies form. New research suggests that supermassive black holes at the centers of these galaxies likely played a major role. Their intense radiation could have amplified the galaxy's brightness, making them look bigger and brighter than they actually are. These black holes may hold the key to understanding the rapid evolution of early galaxies. And here's something closer to home. In cosmic terms, a gas giant exoplanet that's several times the mass of Jupiter and located just 12 light-years away. With a temperature of about 35 FV2C, it's one of the coldest exoplanets ever directly observed. Sure, there are likely even colder planets out there, but what makes this discovery so cool, literally and figuratively, is that we're now able to detect objects in space that aren't fiery hot stars. Finally, imagine a planet where one side is locked in perpetual sunrise, while the other side is forever cloaked in darkness. Let's talk about a planet where one side is always locked in sunrise, and the other side is stuck in perpetual sunset. Using Webb's near-infrared spectrograph, astronomers detected a jaw-dropping temperature difference of about 300 F between the two sides. Any guesses on which side is hotter? You might think it's the sunrise side, but surprisingly, it's the sunset side that sizzles the most. To celebrate its second birthday, James Webb gifted us with a breathtaking infrared image of two interacting galaxies, located a staggering 312.6 million light-years away in the constellation Hydra. These galaxies, charmingly named the Penguin and the Egg, began their gravitational dance between 25 and 75 million years ago. The result? Major distortions in their structure, with one galaxy's spiral arms stretching into the shape of a penguin cradling an egg. Talk about cosmic art. Next, we have a protostar, essentially a baby star still in its formation stages, before nuclear fusion begins. Webb captured a stunning image of this budding star surrounded by an hourglass-shaped structure. This brilliant shape is caused by the protostar's powerful outflows interacting with the surrounding gas and dust. A thin, dark disk of dust cuts through the middle, feeding material into the growing star. It's like watching the universe assemble its next shining masterpiece. Finally, we have a groundbreaking image of the Serpent's Nebula, revealing multiple pairs of bipolar jets shooting out from newly forming stars. These fiery jets illuminate the nebula with vivid energy, offering a rare glimpse into the birth of stars within this mysterious serpentine cloud. Let's dive into the incredible process of star formation. James Webb has captured red jets streaking out from protostars, closely aligned with surrounding gas and dust filaments. This alignment supports the theory that magnetic fields play a critical role in guiding both the jets and filaments as stars come to life. It's like the magnetic fields are the universe's way of choreographing this cosmic dance. Now, onto the Crab Nebula, essentially the remnants of a supernova explosion 6,500 light-years away in the constellation Taurus. With its near-infrared and mid-infrared instruments, Webb has revealed intricate details of this cosmic fallout, including gas and dust filaments and regions of active star formation. It's a mesmerizing mix of destruction and creation, showcasing the cycle of life in the universe. Speaking of beginnings, Webb has also given us a look at a pair of twin baby stars, just 2 to 4 million years old. Using its mid-infrared instrument, Webb detected gas jets streaming from both stars, offering a rare glimpse into their early development. And here's a jaw-dropping discovery: 3 of the oldest galaxies in the universe, dating back to just 400 to 600 million years after the Big Bang. What's even more remarkable is that they're still forming stars. These ancient galaxies pull in cold helium and hydrogen gas from their surroundings, fusing these elements to create new stars. It's like watching the universe light its first fires. Finally, let's talk about WASP 107b, a gas giant exoplanet that's earned a nickname for being puffy. Thanks to Webb's observations, we're learning even more about this fascinating world, which defies conventional ideas about planet formation. Let's talk about WASP 107b, the Marshmallow Planet. Observations show a striking lack of methane in its atmosphere, hinting that the planet's interior is much hotter and its core is far more massive than we thought. That explains its puffy, marshmallow-like appearance, a cosmic oddity that's redefining our understanding of gas giants. Next, James Webb has measured wind speeds on a distant gas giant exoplanet about 280 light-years from Earth. This planet, which always has one side facing its star, experiences wild temperature swings between its scorching day side and freezing night side. The result? Equatorial winds whipping across the planet at an astonishing 8,000 kilometers per hour, redistributing heat in an interstellar storm like no other. Moving on, here's the sharpest infrared image ever taken of the Horsehead Nebula. Okay, so it doesn't really look like a horse to me either, but the intricate details captured are incredible. The image showcases stunning interactions between gas and dust, painting a vivid picture of the nebula's dynamic mane. Then there's this gem, a starburst galaxy 12 million light-years away in the constellation Ursa Major. Unlike the relatively calm pace of our Milky Way, this galaxy is in overdrive, forming new stars at a rate 10 times faster. It's like a cosmic factory, churning out stars at an extraordinary pace. And if that's not enough, James Webb has detected complex organic molecules, including alcohol, in the icy regions of space. Yes, you heard that right. The building blocks of life are floating around in the coldest corners of the cosmos, offering tantalizing clues about how life might emerge elsewhere in the universe. Imagine a molecular cloud packed with alcohol, not the kind you'd sip, but the kind that could play a role in creating life. These findings suggest that alcohol molecules were present during the early stages of star and planet formation, possibly contributing to the development of life-supporting environments in the cosmos. Now let's head to the Triangulum Galaxy, about 2.7 million light-years from Earth. Here, we find a massive star-forming region that's home to over 200 young massive stars in the earliest stages of their development. It's a bustling nursery of cosmic giants, lighting up the galaxy like a galactic fireworks show. Next, we're peering into one of the brightest and most distant galaxies ever discovered, existing just 430 million years after the Big Bang. It's a glimpse into the universe's infancy, and James Webb is helping us understand how such luminous galaxies emerged so early in cosmic history. Speaking of cosmic mysteries, James Webb has provided compelling evidence of a neutron star hiding at the core of a famous supernova, first observed in 1987. For decades, scientists have debated what lay at the heart of this explosion. Now, we have answers, thanks to Webb's revolutionary capabilities. And here's something quirky: many early galaxies seem to resemble pool noodles or surfboards. These bizarre shapes challenge our ideas about how galaxies formed and evolved in the early universe. From the whimsical to the majestic, James Webb also captured a dust cloud resembling a cat's tail, adding a touch of cosmic creativity to its catalog of discoveries. Finally, let's talk about something close to home, a lonely brown dwarf located just 65 light-years from Earth. Using Webb, astronomers have detected a brilliant aurora over the dwarf's north pole, much like Earth's northern lights. But here's the kicker. These auroras might actually be heating the star's upper atmosphere, a phenomenon we're just beginning to understand. Unlike planets, brown dwarfs don't have a host star to drive atmospheric phenomena like auroras. So, where does the light come from? It turns out these dazzling displays are generated by the brown dwarf's own magnetic field interacting with ionized gas in its environment, a fascinating glimpse into the self-sustaining power of these celestial objects. Meanwhile, James Webb turned its attention to Uranus, and wow, did it deliver! Using its near-infrared camera, Webb captured 11 of the planet's 13 known rings, including the faint Zeta ring. This showcases Webb's incredible sensitivity to even the most delicate and faint structures in the cosmos. Next up, we have a stunning high-definition image of what remains after a supernova explosion. Webb's near-infrared view reveals breathtaking details of the expanding shell of material left behind by the exploded star. Bright pink and orange clumps light up the scene, composed of elements like sulfur, oxygen, argon, and neon, a vivid reminder of the building blocks of life scattered across the universe. Then there's this Herbig-Haro object, a brilliantly illuminated region surrounding a newborn star or protostar. These striking formations occur when jets of gas from the protostar collide with surrounding gas and dust at incredible speeds, creating jaw-dropping shockwaves. Thanks to James Webb, we now see these objects with unparalleled detail. And how about a trip to the heart of our own Milky Way? Webb's near-infrared camera has unveiled an extraordinary view of our galaxy's core, revealing around 500,000 stars packed into this dazzling region. It's also identified previously unseen features, including mind-blowing blue, needle-like structures that add to the cosmic wonder of our galaxy's center. Finally, we have another incredible collaboration between James Webb and its predecessor telescopes, pooling their powers to explore even more of the universe's secrets. Let's start with an extraordinary collaboration between James Webb and Hubble. Together, they've created a stunning, comprehensive image of a galaxy cluster by merging Webb's infrared observations with Hubble's visible light data. This vibrant, pan-chromatic view spans incredibly tiny wavelengths of light, unveiling a dazzling cosmic landscape teeming with galaxies, a masterpiece of teamwork across time and technology. Now, on to Jupiter. James Webb has discovered a previously unknown high-speed jet stream in the gas giant's atmosphere. Located above the planet's equator, this massive jet stream spans over 4,800 kilometers in width and boasts wind speeds of 515 km/h. Positioned about 40 kilometers above Jupiter's main cloud decks, this discovery offers groundbreaking insights into the intricate atmospheric dynamics of the solar system's largest planet. Next, Webb has also detected carbon dioxide on the icy surface of Jupiter's moon, Europa, specifically in an area called Terra Regio. Here's the exciting part. Scientists believe this carbon likely originates from Europa's hidden subsurface ocean, rather than external sources like meteorites. Since carbon is a fundamental building block of life, this finding fuels the possibility of life-supporting conditions beneath Europa's icy shell. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.